Welcome to Land Navigation for Search and Rescue. This video is part of a series designed to assist SAR volunteers in acquiring skills essential for safe, effective land navigation in a search and rescue environment. The videos for map reading, compass work, and GPS operation are designed to address Washington State's land navigation core competency requirements for ground searchers. There are two parts to answering the question, where am I? You must be able to find and mark your location on the map, and you must be able to describe and report your location using one of the four coordinate systems: U.S. National Grid, UTM, Public Land Survey System, and Latitude and Longitude. These tick marks are used to define both the UTM and the USNG grids. Locations are expressed in easting and northing coordinates, which define 1,000 meter grid cells and point locations within the grid cells. A hiker is reported missing. He was wearing blue jeans, a white shirt, and a red hat. He said he was headed to Deep Lake. Your team has been assigned to search along the trail. You find a red hat at the location indicated. Now you need to report the location of the hat. To read the UTM coordinates of a point, first establish the grid lines and identify the grid cell which contains the location of the red hat. Read right up. The easting coordinates increase from left to right, and the northing coordinates increase from south to north. The principal digits which define the grid cell are identified by tick marks on the edge of the map. Refine the location using your estimation skills. With practice, you can estimate the easting and northing within 5% or so. Certainly close enough, especially with a topographic reference included in your location. Note that this estimation process will provide accurate coordinates no matter what the map scale. Your answer is custom fit to your map. Read the easting coordinates from the right. Read right. Use your estimation skills to read the northing coordinates. Read up. UTM coordinates can now be completed by adding the distance from the bottom of the grid cell to the red hat. UTM is a worldwide system. Adding a grid zone designation completes the UTM coordinates. If you need to communicate with someone outside your region, use the full UTM coordinates. Identify the grid cell. Refine your coordinates. Always include a description of the topography. The U.S. National Grid is an adaptation of the UTM and military grid reference systems, designed to create a unifying national standard for defining and reporting location. To support this effort, the U.S. Geological Survey has produced a new format for the traditional 7.5-minute topographic maps. This new format emphasizes the use of USNG coordinates. For search and rescue, USNG and UTM are equivalent in defining location. The two systems differ only in the format of the presentation of the full coordinates. For ground searchers, two sets of 4 digits, when combined with a topographic reference, is sufficient. USNG coordinates. Easier to read, easier to communicate, the preferred national standard for emergency management. Always include topography and ground cover in your report. In Washington state, there is a difference of approximately 220 meters in grid line locations between the old NAD 27 datum and the new NAD 83 and WGS 84 datums. Before you set out on a search, make sure that the datum on your GPS and your map is appropriate for the search. This app provides quick access to the coordinates of your location. It does not require cell coverage. When air support is available, SearchBase will communicate locations with the aircraft using latitude and longitude. Look for the red dot up in the Pacific Northwest and estimate its latitude and longitude. Latitude and longitude are usually expressed in the format shown on U.S. Forest Service and U.S. Geological Survey topographic maps. There are three commonly used formats. A 7.5-minute topographic map covers an area of 7.5 minutes of latitude by 7.5 minutes of longitude. The map is divided into 9 units, 2.5 minutes by 2.5 minutes. 2.5 minutes is equivalent to 150 seconds. If you are careful and thoughtful, you can easily divide a line in half, and then half again, and by repeating this process, generate an estimate of the latitude and longitude of a point. To read the latitude and longitude of a point, first establish the encompassing grid reference points. Box the point. To estimate the longitude of a point, we need to estimate the angular distance from our reference point. Use your estimation skills. 60% of 150 seconds is 90 seconds, which converts to 1 minute and 30 seconds. Adding this angle to our reference longitude gives the longitude of the viewpoint. Estimate the location of the viewpoint as a percentage of the distance between the reference marks. Convert the percentage to seconds. Convert to minutes. Add to the reference latitude. With practice, you can estimate latitude and longitude within 5% or even closer. The really good news about this process is that it is entirely independent of the map scale. No rulers or gadgets required. No matter what the scale, and you don't need to know it, you can get reliable estimates of latitude and longitude. What are the latitude and longitude coordinates of the red hat? First, box the hat. Establish your reference points. Estimate the percent change from the reference points. Compute the changes in minutes and seconds. Calculate the latitude and longitude. The Public Land Survey System, when combined with a description of the topography, provides a quick, simple, adequate method for describing your location. The Public Land Survey System is designed to describe land areas. For this class, we will focus on the section as the basic unit of this system. A standard section is a square area of land 1 mile on each side, containing 640 acres. The exact location of any section in the United States covered by the Public Land Survey System can be defined by referencing its township, range, and meridian. This map shows areas covered by the Public Land Survey System. Each green line is a principal meridian, and the red lines are the associated baselines. The Public Land Survey System in the states of Oregon and Washington is governed by the Willamette Principal Meridian, and the origin of the system is a spot in Portland, Oregon, where the baseline and the meridian cross. The Public Land Survey System is implemented by surveying a principal meridian, a baseline, a series of township lines, and a series of range lines, each separated by a distance of 6 miles, thus creating a grid of townships, each 6 miles on a side and containing 36 sections. This is Township 8 North, Range 5 East. It covers the south side of Mount St. Helens. Look at the arrangement of the sections and the unique numbering sequence. Section 1 in the northeast corner and Section 36 in the southeast corner. The good news is that the Public Land Survey System location does not require any computation, no rulers or scales, just a knowledge of the system and the ability to read the information from the map. Now let's look at how the Public Land Survey System is used to describe areas of land. The Public Land Survey System defines areas of land by section, township, and range. All of Washington is covered by the Willamette Meridian. We are on the trail, in a saddle, at an elevation of 4,120 feet, in the northeast quarter, Section 31, Township 11 North, Range 6 East. This bearing tree is part of the Public Land Survey System, and it will give you your exact location if you can read the writing on it. This brass cap, referenced by a bearing tree, if one is available, gives you an exact location. I am on the trail in a saddle at approximately 4,200 feet, and my coordinates are 10T ES 69375 38500. I'm on the trail in a saddle at approximately 4,200 feet, and my coordinates are 10T 0569375 5138500. I'm on the trail in a saddle at approximately 4,200 feet, and my coordinates are latitude 46 degrees 24 minutes 0 seconds, longitude 122 degrees 06 minutes 00 seconds. I'm on the trail in a saddle at approximately 4,200 feet, and my coordinates are the northeast quarter of section 31, township 11 north, range 6 east. Errors in reading and reporting coordinates are, unfortunately, a common and serious problem in search and rescue. Stressful situations exaggerate this problem. Ground searchers will normally be given a map with a coordinate system chosen by the incident command team. You must be able to work with the system chosen for your search. The correct format for reporting coordinates should be understood before you leave search base. It is your responsibility to set the correct datum on your GPS. Okay, let's do a practical example. What are the coordinates of Mount Mitchell? The first thing we want to do is find the grid square and identify this lower left-hand corner. The coordinates are 6196. So now we want to refine our estimate of the coordinates. We'll do the easting. So between there and there, it's about halfway. That's about 75%. So we're 75% of the way between 61 and 63. So that's 2,000 meters across there. 75% of 2,000 meters is 1,500. We'll add that to the 61. We'll get coordinates of 62,500, which we could just call 6250. Then we'll do the northing, so we start from the bottom. We're going this distance here. We're going to estimate the proportions. Halfway. Oh, I'll call that 75% also. 75% of 2,000, 1,500. So the northern coordinates are 96 plus 1,500, which would be 97,500, but we'll just call it 9750. So the coordinates of Mount Mitchell are 6250 and 9750.